Hi there, welcome to the video. My name is Upol, and on behalf of my co-authors, Samir, Vera, Larry, Ethan, Michael, and Mark, I'm excited to share the key highlights of this work on the who in Explainable AI. By the end of this video, I hope it will add a new dimension to how you think about this problem. So this work started with a very simple question. Does the presence or absence of one's AI background impact one's interpretations of AI explanations? Well, the short answer to that is yes, it does. But stick around till the end of the video to find out why and also learn about a new type of negative effect in Explainable AI. Now, let's begin by addressing a very crucial point. Why does the who matter? For Explainable AI or XAI, we often hear the saying of opening the AI's black box. But while opening the AI's black box is important, who opens it matters just as much, if not more. This is because the who scopes how to share the why. For example, engineers of self-driving car require different types of explanations than writers. Actually, let me share this using a real-life example. A while ago, I had the chance to ride an Uber self-driving car back when it was in its research stage. Next to the backup driver was this engineer who helped me understand what the car was doing by translating the data and numbers on his laptop into plain English so that I could understand. It was clear how I, as a writer, had different explainability needs than him as an engineer. This moment also highlighted how our different AI backgrounds impacted how we interpreted what the car was trying to tell us. Which brings us to the central part of this paper, AI background. In this paper, we systematically investigated how the presence or the absence of one's AI background impacts one's interpretations of AI explanations. But you might be wondering, why should we bother with AI backgrounds? Well, you see, AI background is a very important and consequential user characteristic because of its disparity between the creators of the technology and often the consumers of the technology. We often call it the creator-consumer gap in XAI. This gap actually is one of the many reasons why a lot of XAI interventions often fail in the real world. So here are the three things we're going to learn today. We're going to learn what AI explanatory preferences are between two groups, people with and without an AI background, how one's AI background influences the perceptions of AI explanations and why that is the case, and we'll also identify a new type of negative effect in XAI, one that is not intentional, but leads to problems nonetheless. So what did we do in this paper? Let us begin with the methods. At a high level, we ran a mixed method study to investigate how two groups, with and without an AI background, interpreted three different types of explanations along 5 dimensions. Let's break it down. I'll first start with the group formation. So we used a systematic approach to create these groups. A total of 179 people participated. The AI group had 96, the non-AI had 83. But both groups had to go through this systematic screening that had 3 parts to it. The first was a CS and AI knowledge test. The second was self-reported levels of AI expertise and knowledge. And the third was whether they have taken a class or not. And we ensured that the non-AI group had no prior classes and self-reported as having no prior AI knowledge. Thankfully, the groups are indeed measurably different when it comes to AI background, but they do not have a significant difference in age or education levels. Now, let's look at what the participants did, which is the task. So in this case, participants pretended to be space explorers in a search and rescue mission facing a life and death situation. And their only hope is to rely on these autonomous robots that you can see in the screen that they cannot control to retrieve the package that they need to survive. So participants watched the videos of these robots behaving identically, succeeding and failing in the same way. And the only difference between them is how they kind of explain themselves. So let's start with it. On the left-hand side, we have the rationale generating robot, which is the language with the justification. In the middle is the action declaring robot, which just states what the actions are. So you can think of it as the what robot. And on the right-hand side is the numerical reasoning one, which spits out these numbers, which are unlabeled. Remember, participants do not know what these numbers are, but just between you and me, these are actually Q values of a reinforcement learning agent. One thing to clarify, only RG, or the rational generating one, was designed to provide the why. While NR, the numerical reasoning one, could in theory provide a mechanistic understanding of the how, the unlabeled natures should make it almost impossible. Moreover, Q values do not explain why one action has higher utility than others. And after watching the videos, participants ranked each robot along these 5 dimensions and justified their choices using open-ended text responses. And these dimensions are grounded in the literature around trust and autonomous systems in HCI, XAI, and HRI. Now, with these methods in mind, let's dive into the analysis and the findings. So as we shared earlier, we used a mixed method approach, quantitative and qualitative, to answer two questions. Quantitatively, what are the explanatory preferences of people with and without an AI background? And qualitatively, how and why do differences in AI background result in these different interpretations? Let's start with the quant part first. So to get the between group differences and preferences, we ran an ordinal logistic regression. The rational generating one, the RG one, is the overall winner, and that's great, but the game gets really interesting when you start focusing on AD and NR. So these odds ratios, so any odd ratio over a 1 means that the non-AI group prefers that robot. So the non-AI group prefers AD, the action declaring one, over NR, and the AI group actually has the opposite preference when it comes to their choices of robots. It prefers the NR over AD. Now the question is, why? And this brings us to the qualitative part, which is where we ask the question, how and why do group differences in AI background result in these different interpretations? To answer this, we analyzed the open-ended justifications that people provided for their ranking using grounded theory. At a high level, we started with an open in vivo coding that was then merged. We analyzed the data using axial codes, finding connection between open codes. Finally, we merged the axial codes into high-level themes using the heuristic of constant comparison in grounded theory. And this consolidated into the most salient themes or the selective codes that led to our findings. And boy, were we in for a surprise. So the first key finding was that both groups had unwarranted faith in numbers. They associated the presence of these numbers with the presence of an algorithmic process, even when the numbers were unclear to them. But the reasons for this association was very different for each group. And this is where heuristics can help us, which are mental shortcuts. These heuristics used by each group linked to their respective backgrounds can help us unearth why this was the case. For the AI group, they followed the heuristic reasoning that associated numerical representations with logic and intelligence. As this person puts it, while I don't understand the numbers clearly mean that there is a smart algorithm in the backend. And this person had this golden quote, math had an aura of intelligence. Now, for the non-AI group, their very inability to understand the complex numbers was associated with the presence of a higher order intelligence. For example, as this person puts it, because I couldn't understand the numbers, I deemed it to be intelligence. And another person echoes, numbers had a mystery and an aura of higher intelligence. Now, moving on to the next finding, we need to recall that RG was the only one designed to provide the justification, or the why. Yet, both groups found unanticipated explanatory value in other robots. And this is where the lens of appropriation comes handy, which is an unexplored area in XAI. Each group had different explanatory intent that is connected to their AI background and thus appropriated AD and NR differently. Let's dive in. For the non-AI group, they had a desire for affirmation, confirming the action without necessarily explaining it. Thus, they appropriated AD's confirmatory statements as a signal for stable system behavior. As this person puts it, AD is consistent and nothing goes crazy. It never said it would go right, and then it actually went down. For the AI group, however, they had an explanatory intent of diagnosis and thus ascribed diagnostic value to NR's numbers even when their meaning was unclear. In fact, this diagnostic intent is connected to their background. As this person puts it, as an engineer, I want to fix things. Even if I don't understand these numbers, I can manipulate them and try to debug them. With the AI stuff I'm learning, I can use it to diagnose. So what do these findings do for us, and how do they advance our knowledge? Here are 3 things. First, it extends the literature of heuristics-based decision-making in XAI. Our findings connect what heuristics people use, how their AI background influences their thinking, and explain why that is the case. Second, we add these lenses of user appropriation, which has been a very underexplored topic in this area, and it has implications on user agency. Third, and here is a pro tip, when it comes to designing good AI explanations, we need to remember that people will find explanatory value in unexpected ways, regardless of what we do. This is because explanations are both products and processes. The way people make sense of explanations matter just as much as what these explanations are. Now, we have some time for implications. Let's start with design implications. As you'll remember, different groups use different heuristics or mental shortcuts that led to problematic interpretations. So what we need to do is we need to increase effortful System 2 thinking, so this is coming from Daniel Kahneman's System 1, System 2 thinking, and decrease fast System 1 thinking. So at the time of decision making, we can use things like cognitive forcing functions, which are prompts, delays, to promote critical reflection. For For example, for the AI group to prevent overtrust in numbers, what if they were prompted to reflect on the value of these numbers? I want to be clear here. The goal is not to eliminate heuristic reasoning, but to find the balance between heuristic and deliberative thinking. The next design implication is around appropriation. So users will appropriate no matter what. The goal is to support, not control. And to aid in this process, we can use our recent work on seamful explainable AI, where imperfections in AI are turned into opportunities for better user understanding and agency. In our case, revealing the lack of the explanatory power of these Q values could have prevented the AI group from misappropriating them as having diagnostic value. Finally, some research implications. Why does this matter for research? First, despite best intentions, we saw that problematic interpretations of AI explanations emerged. This is actually an example of explainability pitfalls. Explainability pitfalls are a new type of bad effect in XAI. They're not dark patterns. In dark patterns, there is an intent to deceive. In explainability pitfalls, it's unintentional. And explainability pitfalls are heavily underexplored. And by identifying them, we're extending our thinking about harms in XAI, and we can help go beyond just dark patterns, which addresses a key pain point in the community. Now, let's wrap up with some reflections. First, our findings illustrate who opens the AI's black box is just as important as opening it. And in fact, without any intent to deceive, we found explainability pitfalls around unwarranted faith in numbers. Now, I want you to imagine how bad faith actors could weaponize these pitfalls for nefarious reasons. This means this is a call to action for HCI and AI communities to form coalitions and build on this work to further explore the who in XAI. With that said, thank you for watching. If you like it, share it with your friends. If you have questions, email us. If you end up at Kai in Hawaii, ask us in person. Thank you so much.